Hello friends, welcome to engineering tutorial. So in the previous video we discussed the basic concept about superposition theorem, the basic introduction, and we discussed one simple question on the application of superposition theorem. So in this video we are going to discuss another question, be the second question. So again it will be on the application of superposition theorem. So we have this circuit and we have to determine this current I. Okay, so we have to apply superposition theorem. So as you can see, this circuit, it consists of two DC voltage sources, 50 volt on the left, 10 volt on the extreme right. So we have to do it in two steps. First we have to consider 50 volt voltage source, short circuit the 10 volt voltage source. Then we have to consider the 10 volt voltage source, short circuit the 50 volt voltage source. So first, the step 1, we are going to consider the 50 volt voltage source short circuiting the 10 volt voltage source. The circuit, it will look something like this. Ohm. This is short circuited. Okay, this 10 volt is short circuited. Now if you look closely at this circuit and you look at this 40 ohm resistor and 5 ohm resistor, see, there are two ends, these two ends are connected together, 5 ohm this end, 40 ohm this top end, and their right ends, okay, this and this, they are shorted. It means 5 ohm and 40 ohm are in parallel. 5 ohm and 40 ohm are in parallel. Now I have already posted a lot of videos on the calculation of equivalent resistance in a complicated circuit. I have posted around 6 videos I think, so you can check out those videos in the circuit theory playlist. So the 5 ohm and 40 ohm, they are in parallel connection. So first we will determine the equivalent resistance of these two. 5 parallel 40, it will be 5 into 40 by 5 plus 40. So it will be 200 by 45. Let me calculate. It is coming around 4.44 ohm. Okay, so we will replace this with a 4.44 ohm, and also this circuit will change. Okay, I am changing it here. So we have replaced these two circuit with the equivalent resistance 4.44 ohm. Okay, this resistance. Okay, now we have to determine this current flowing through the 40 ohm resistor. We will come to it. Okay, we will come to that. So now this 5 ohm and 4.44 ohm, they are in series. This 5 ohm and 4.44 ohm, they are in series. So if we want to determine this current, we have to determine. In order to determine this current due to the 50 volt voltage source, first we have to determine this current I. Let's call it, here it is I, so let us call it IO, let us call it IO. Okay, 5 ohm and 4.44 ohm are in series, okay, across this 50 volt voltage source, okay. So this current I0 or I naught would be 50 by 5 plus 4.44, which is equal to 50 by 9.44, 50 volt by 9.44 ohm. So that is equal to, let me calculate, it is coming as 5.296 ampere, okay, this current. So we have got this current. Now again we will have to redraw the circuit, okay, to the original form. This current is 5.296. We did all the equivalent resistance calculation in order to determine this current. Now we will redraw the circuit to its original form. It means this will become 40 ohm, this is 40 ohm, and this is again 5 ohm. There we calculated the equivalent resistance and we got 4.44 ohm. It was easy to calculate this 5.296 ampere. Now this is 5.296 ampere and we have to determine this current. Let's call it I dash, okay, step 1. Let me erase these parts. Now if you look closely at this circuit, so 40 ohm, this is a 5 ohm, and this is I naught equals to 5.296 ampere, which we just calculated. We have to determine this current I dash. Again we have to apply current division rule. Current division rule. The direction of I dash, it is very important, it is, we have taken it downward. The original current direction which we have to determine, that is also downward. That is very important because this is the reference, okay. All the calculations have to be done with respect to this. Here we have taken this current direction as downward. It is okay as per our choice. So now here we apply current division rule, okay. I dash is equal to 5.296 into the opposite resistance, the other resistance, okay, 5.296 into 5 by 5 plus 40, the sum of the resistors. Now I have already posted videos related to current division rule, voltage division rule, source transformation, star delta transformation in the circuit theory playlist. It is there, so you can check out those videos. So this value of I dash, it will be, let me calculate, 5 into 5.296 divided by 45, it is coming as 0.589 ampere. So this is very important, the value of I dash. I dash is equal to 0.589 ampere. Now important thing, this is the value of current because of the 50 volt voltage source. 50 volt voltage source considered alone, the 10 volt being short circuited. Now we have to consider the 10 volt voltage source and short circuit the 50 volt voltage source, and let's see what the value of current will be. Then we will combine them together to get this current I. Okay, step 2, let us do that. So this is because of 50 volt only. So this is step 2. We have to consider the 10 volt voltage source and short circuit the 50 volt voltage source. So let us do that. So here it is, the 50 volt voltage source short circuited, this okay. 10 volt, 20 ohm, 5 ohm, 5 ohm, 40 ohm. Okay. So now again, if you pay attention to this 5 ohm resistor and this 40 ohm resistor, again these two ends, okay, they are connected at one point, and these two ends, they are shorted because of this 50 volt voltage short circuited. These 2 points are shorted. It means 5 ohm and 40 ohm are in parallel connection. They are in parallel connection. So again we have to find the equivalent resistance, 5 parallel 40. I think the previous step also it had the same value. It will be 5 into 40 by 45. So it will be 4.44 ohm, the same result. So again we will replace this, redraw this circuit, okay, and replace it with the equivalent parallel resistance. So it will be 4.44 ohm. Now we have to determine this current. Okay, let's again call it I naught. Okay, so this current I naught, this 5 ohm and 4.44 ohm, they are in series connection across this 10 volt voltage source. So again naught will be the voltage, the total voltage divided by the total resistance, which is 5 plus 4.44 ohm. So it will be 10 by 9.44 ohm, which is equal to, let me calculate, 10 by 9.44 is coming nearly 1.059 ampere. Okay, so this current we have found out, 1.059 ampere. Now again we will redraw the original circuit. Okay, we did all of this, the equivalent resistance and all of that, to find out this current, okay, I naught. Now let us redraw the circuit. It means this will again become 40 ohm. We did the same thing in the previous step as well, and we will redraw it as 5 ohm. Now we have to determine this current I double dash, let us call it. Okay, so let me remove these portions. So now let us draw it. This is equal to 1.059 ampere. This is 40 ohm. This is 5 ohm. We have to determine this current I double dash. Now the direction of the current, again it is also downward. The original reference direction is also downward. Okay, that is very important. Again here we have to apply the current division rule. Current division rule, if we apply, I double dash will be 1.059 into the other resistance, which is 5 ohm, by the sum of the resistance, which is 5 plus 40, which is 45. So let us calculate it. It will be 5 into 1.059 divided by 45, 0.1176, or let us call it 0.118 ampere downwards. This is very important. The direction of the current is very important. This is downward. Now if you remember in the previous step, okay, in the previous step we calculated the value of I dash because of the 50 volt voltage source as 0.589 ampere downward. That was also in the downward direction. Okay, so I dash is downward 0.589 ampere, I double dash is also downward 0.118 ampere, and the original current direction which is being asked here, it is also downward. So the total current I will be I dash plus I double dash, which is equal to 0.589 plus 0.118, which is equal to, just calculate, 0.589, 0.11, 0.707. Okay, so this is the current which is being asked through the 40 ohm resistor. Direction is downward. Now, an important thing which I would like to tell you is that the direction of current which is there in the question, it is fixed. We cannot change that. Okay, it is downward. But the direction of the currents that we take while applying the superposition theorem, that is in our hand. Okay, we can take it in any direction as we want. Now, if here I double dash would have been in the upward direction, I double dash, let's say, would have been in the upward direction, we would have taken it in the upward direction, then here while calculating the result, it would have been I is equal to I dash minus I double dash, because the upward direction is in opposition with the direction of the current which is being asked in the question. Okay, now let us say both I dash and I double dash would have been in the upward direction, then it would have been minus I dash minus I double dash. Okay, minus I is equal to minus I dash minus I double dash, because they are both opposite to the direction which is being asked in the question, which is downward. So you get the point. The summation should always be done with respect to the original direction of the current which is there in the question, or in case of voltage, the voltage polarity which is there in the question. Okay, so always this acts as the reference. Okay, the original direction of current or the polarity of the voltage which is there in the question, that is the reference. All the other summation analysis has to be done with respect to that. Okay, here both I dash and I double dash were in the downward direction, so we just added them. I is equal to I dash plus I double dash. Okay, so here we got the result. This is the second question that we solved related to superposition theorem application. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.